Okay, welcome back to this class. In this class, we are going to continue with derivative of implicit functions. So the first question that we have, so if you're just joining this channel, don't forget to subscribe, like, and share this video, share with your friends. If you have undergraduate friends, share with them. So the first question that we have is find the y dx and the square y dx squared at point 1, 1 on the curve x cubed plus y cubed equals 2. So we are going to find first derivative and the second derivative at this point on this curve. So that means the first thing that you have to do is you differentiate this. So you find the y dx and the square y dx squared. So solution. So we have the curve to be x raised to power 3 plus y raised to power 3 equals to 2. So we want to differentiate this. So first, you know that this is implicit function. So you differentiate it as implicit function. That is, we want to find d of x cubed, d dx of x cubed plus d dx of y cubed equals to d dx of what? 2. We differentiate all this with respect to x. So from what we have here now, from this, derivative of x cubed with respect to x now becomes what? 3x squared. 3x squared. So now derivative of y cubed with respect to x. So in our last class, when we started derivative of implicit functions, so if you're just joining this channel, kindly go back to my channel. So we started this. We had a class before this where we started this implicit function. So I explained to you how we differentiate implicit functions. When you're differentiating implicit functions, whenever you see y, the dependent variable, you treat it as a function. So in this case now we have y cubed. Y cubed is a function of another function because y cubed is a function of y. Y cubed is a function of y, and y itself is a function of what? X. So you can see it's a function of another function. So that means first we differentiate y cubed with respect to y, and then multiply it by the derivative of y with respect to x. So the meaning of that is that, from here you have y cubed. So that will be equal to plus the derivative of y cubed with respect to y. That will be 3y squared. Now we are going to differentiate the y, that is y with respect to x. The derivative of y with respect to x is equals to what? The y dx. Get that? So equals d dx, that means differentiate with respect to x. The derivative of constant is what? 0. So from what we have here now, we have 3x squared. So that means we want to find the y dx. So that means we're going to make the y dx the subject of the formula. 3y squared dy dx equals to, bring 3 in, that will be equal to 0 minus 3x squared. So from here now we have dy dx. So you can divide both sides by 3y squared equals to minus 3x squared all over 3y squared. So from here now 3 cancel 3. So that means dy dx is equals to minus x squared all over y squared. So dy dx is equals to minus x squared all over y squared. So that's dy dx. So then we find the square y dx squared. So how do you find the square y dx squared? That means this is the y dx first derivative. To find the second derivative, that means you differentiate the y dx again. That will give you the second derivative. The y dx is equals to minus x squared all over y squared. Now to find the square y dx, so that means you are going to differentiate this again. So but from what we have right now, we have them to be quotient. That means you apply quotient rule. But don't forget, we are still dealing with implicit function. So from what we have here now, implies the square y dx squared will be equal to, you remember quotient rule, v du dx minus u dv dx all over v squared. Pick this, pick the denominator, differentiate the numerator, minus pick the numerator, differentiate the denominator, all over square this. So from what we have now, our v is what? Y squared. Du dx, differentiate this with respect to x, and that will be equal to 2x minus u. Let's give this x squared our minus u. That means our u is minus x squared dv dx. That means you differentiate y squared. Don't forget we are dealing with implicit function. So this y squared, you're going to differentiate it as a function of another function. So first you differentiate y squared with respect to y, which is going to be 2y. Now you will differentiate y. So the derivative of y is what? dy dx. So that means we have 2y dy dx all over v squared. Y squared, everything squared, that's y raised to power 4. So do you get that? Implies the square y, the x squared will be equal to, so we have this multiplied by this 2x y squared minus and minus that was plus minus 2x squared y 2x squared y dy dx 2x squared y dy dx all over. Oh, don't forget that we have it to be equal to what? 0. Don't forget though. So from here now, dy dx will be equal to, sorry, minus this. So the square y dx will be equal to all this. Okay. Alright. So dy dx, what we have? Okay. All over y raised to power 4. Y raised to power 4. Y raised to power 4. So what we want to find is what? The square y dx squared. So here we have it, the square y dx squared to be this, all this. But from what we have here now, you can see that I think y is common to the denominator, right? So y is common. That means we can have it as y into bracket 2xy plus 2x squared dy dx all over y raised to power 4. So y we cancel and we have y raised to power 3, right? The square y dx squared will be equal to 2xy plus 2x squared dy dx all over y raised to power 3. So this is our second derivative. So but the question says find the y dx and the square y dx squared at point 1, 1. So that is at point 1, 1 at 1, 1. So which implies at that point x is equal to 1 and y is equal to, and y also is equal to what? 1. So that means that's the meaning of point 1, 1. It implies x equals to 1 and y is equals to 1. X equals to 1 and y is equals to 1. So from what we have there now, so if we apply this, that means your dy dx, dy dx will be equals to, dy dx is equals to minus x over y squared. So that will be equals to minus, what's our x? 1 squared. What's our y? 1 squared. So that will be equals to minus 1. So it implies the y dx is equals to what? Minus 1. You get it? At point 1, 1, the y dx is minus 1. Now, what will be the square y dx squared at point 1, 1? The square y dx squared, what will it be at point 1, 1? So from what we have here now, these are the square y dx squared. So now at point 1, 1, that is x will be equal to 1 at that point, y also will be equal to 1, and at that point, the y dx is equal to what? Minus 1. So we're going to plug all those values into this equation, right? So it implies we have the square y dx squared at point 1, 1. The square y dx squared at point 1, 1 will be equals to Square y dx squared at point 1 comma 1 comma 1 will be equals to 2 into bracket x is what? 1, y is what? 1 times 1 plus 2 into bracket 1 squared, x is 1. So the y dx is equals to what? At point 1 comma 1 is what? Minus 1 of this times minus 1 all over, what was our y? 1 raised to the power 3. So let's solve another example. Okay, so this is the second question. So the question says, find the y dx and the square y dx squared if x plus y plus sine y equals 7. So find the y dx and square y dx squared. So solution to this, so we have the solution to this is that, so that means we differentiate this, we find both the first and the second derivative of this equation. So we have x plus y plus sine y equals to 7. So to find the first derivative, that's we differentiate all this with respect to x. That is d dx of x plus d dx of y plus d dx of what? Sine y equals to d dx of what? 7. So from what we have there, so derivative of x is what? 1 plus derivative of y is what? Dy dx plus derivative of sine y. So now sine y is a function of another function. So sine is a function of y and y is a function of what? X. So that's function of another function. So first we differentiate sine with respect to y. So derivative of sine y is equal to what? Cos y. So then cos y. So then we differentiate the y, so which is the angle. So derivative of y is what? Dy dx equals to derivative of 7 constant. So derivative of 7 is a constant. So that will be 0. So from what we have there now, we find our dy dx. We find our dy dx. So from here, so we can say dy dx plus cos y dy dx cos y dy dx equals, so bring 1 here, that will be cos to minus 1, 0 minus 1 minus 1. So you factorize dy dx. Dy dx will be equal to 1 plus cos y equals to what? Minus 1. So from there now, differentiate, divide both sides by 1 plus cos y, implies dy dx will be equal to minus 1 all over 1 plus what? Cos y. So that is dy dx minus 1 all over 1 plus cos y. So then the next thing is we're going to find the square y dx squared, which means we differentiate this dy dx. So second time, for the second time. From there we have that dy dx is equal to minus 1 over 1 plus what? Cos y, minus 1 over 1 plus cos y. So to find the square y dx squared, the x squared. So that means we're going to differentiate this for the second time. So we can simply use quotient rule. So if we are going to use quotient rule, this is our u and this is our v. You get that? So that means we say v1 plus cos y du dx, the derivative of minus 1 is what? 0 minus u, what was our u? Minus 1. dv dx, so that means we're going to differentiate this. The derivative of 1 is what? 0 plus the derivative of cos y. So remember, we are still differentiating with implicit functions. So the derivative of cos is what? Minus sine. So that the derivative of cos y, first you differentiate with respect to y, then you differentiate y with respect to x. So multiply both together. So from what we have now, the derivative of cos y is what? Minus sine x minus sine y, sorry rather. So that now you differentiate y, dy dx, minus sine y dy dx, all over 1 plus cos y, everything squared, that is v squared. So from there, so what you have from there is that the square y, the x squared will be equal to 0 times this is 0, minus and minus, that's plus, 0 plus this, that's minus. So that means here now all we have left will be equal to minus sine y dy dx all over 1 plus cos y, everything squared. So that is the square y dx, so the second derivative, minus sine y dy dx all over 1 plus cos y, everything squared. So, well, you can decide to make it linear. So if you want to make it linear, so then you're going to have multiply this, like cross multiply, you're going to have 1 plus cos y squared, the square y, the x squared, the square y, the x squared, plus sine y dy dx equals 0. So that means I multiply this by this, I bring this to this side, and because it becomes a what? A second order differential equation. So we're going to get to that on this channel. I hope so. We'll get to the differential equation, first order, second order. So how do you solve the solution of the differential equation? So this is where we're going to stop in this class. So this is where we'll stop in this class. So I'll see you in the next class where we're going to finalize the derivative of implicit functions. So don't forget, if you haven't subscribed, don't forget to subscribe to this channel. I'll see you in the next class.